Alright, logic fans, what's up? Welcome to our third video on section 1.1, so 1.1c here, and what we're going to do is we're going to round out our study of validity and soundness and these sort of different properties of arguments, okay? And so by the end of this video, you're going to have a really systematic overview of all the nuances of these properties of arguments. So let's go ahead and jump straight in here. Here what I'm looking at are four sort of, we'll just say loosely, possible kinds of arguments. In fact, at least one of them is not possible, but quadrant A here is an argument with the two properties valid and sound. Okay. Quadrant B is an argument which is valid and unsound. Quadrant C, invalid and sound. Quadrant D, invalid and unsound. Okay. What I want you to do is run through this really quickly and tell me whether or not you think an argument with these two properties, valid and sound, is possible. Yes or no? Is an argument with these two properties, valid and unsound, possible? Yes or no? Likewise for C and D. Pause now. Alright, hopefully you've had a chance to pause it, but let's go ahead and look at quadrant A. Is an argument like this possible? Yes, absolutely. You can have an argument which is both valid and sound. Quick follow-up. Can you give me an example of such an argument? Your hint, we did one in the previous videos. Pause now. Okay, hopefully you got a chance, but yeah, this is just our old friend, all whales are mammals, all mammals are vertebrates, therefore all whales are vertebrates. And there's plenty of other examples in the textbook, but these three dots here just mean therefore, and QED is Latin for being what was to be demonstrated and signals the end of a demonstration. Okay. Moving on to quadrant B. Is quadrant B possible? Yes or no? And if it is, can you provide me with an example? And the answer, of course, is that yes, this is absolutely possible. And again, this is just our old friend, the dinosaur argument, right, that we discussed in the previous video. Again, there's other examples in the book. Now, I want you to hold on to these examples, okay, because in a minute we're going to use them. We're going to use them at the end of the video, okay, in an important way. You'll see. Moving on, is it possible to have an argument which is both invalid and sound? All right. The answer is no. A defining feature, right, of soundness is that it's valid. All right. So all sound arguments are valid, but not all valid arguments are sound, as we see here. This is a valid and unsound argument, right? Last one, is it possible to have an argument which is invalid and unsound? And if so, could you provide me with an example? If it is possible, you have not seen an example yet. So pause now and see if you can come up with an example if this is indeed possible. Okay, so an argument with these two properties, invalid and unsound, is indeed possible. And let's do an example together really quick here. So an invalid and unsound one. Typically, these are arguments which just have premises and conclusions which are completely unrelated. They bear no relationship to one another. So grass is green and, oh, I don't know, Saturn is a planet. And let's do, I don't know, maybe we'll just do a false one, but let's do Dickens wrote Peter Pan, something like that. Okay, so notice the premises and the conclusion are completely, disconnected and unrelated to one another. So that's going to guarantee that it's invalid, and because it's invalid, it's not going to be sound. It will be unsound, right? But yeah, in this case, okay, the two premises are both true and the conclusion is false, but so the reason it's unsound is that it's invalid. Okay, all right, so hold on to these examples and let's go ahead and take a bird's eye Olympian perspective, sort of like 1,000 miles up view of all the different nuances and sort of properties that arguments could and could not have. Okay, so let's present it this way. Okay, So let's present it this way. What we're looking at here is an exhaustive table of sort of all the different ways you could combine properties of an argument. Okay, now some of these are actually not possible, as we're going to discuss, but let me give you the idea here. So I want you to look at it row by row. So here's a row, here's a row, here's a row. There's 16 total of these rows, okay? In this first row here, you're looking at, or you're imagining in your mind's eye, an argument which has this property. It's valid, so Y means yes. It's sound, all of its premises are true, and it's got a true conclusion. But in row 2 here, you're imagining an argument which is valid, sound, has all true premises. It does not have a true conclusion, so N means no, in which case that means it's got a false conclusion. Okay. And similarly, if you had a no here, it would mean it's not the case that the argument has all true premises, which would mean it's got at least one false premise. Okay, so these are all, and I've kind of color coded them here, these are all different properties of arguments, and you've got to sort of track the relationships between them. Okay, now here's an exhaustive table of 16. Okay, but some of them are in fact not possible. Some of them are impossible given our definitions. Okay, so let's start the process of eliminating some of these 16 and narrowing it down a little bit. So to start off with, by definition, all sound arguments are valid. That fact will allow you to eliminate 4 of these 16. Can you tell me which 4 of these 16 can be eliminated based on the fact that all sound arguments are valid? Pause now. Okay, hopefully you had a chance to pause and work it out, but basically the idea is if it's sound, it's got to be valid. So if you have a yes in this column, you better have a corresponding yes in this column, right? As you do in these first 4 cases, so they're all okay. None of these arguments are sound, so we don't have to worry about those cases, but these arguments are sound. And look at this, they're not valid, but the definition of soundness requires validity. So these 4 arguments right here are in fact not possible, and we can eliminate every single one of them. Okay, those are actually not possible arguments. All right, so we're down to 12 from 16. Now, you also know that all sound arguments have all true premises by definition. So if you have a Y here, you better have a Y here. That will allow you to eliminate 2 more from this. Which 2? Pause now. Okay, hopefully you had a chance to pause and think about that, but it's these 2, right? These 2 are sound, but they do not have all true premises, but the definition of soundness requires all true premises, all right? So those 2 can be eliminated. All right, 2 more steps. The next step is that any argument which is both valid and has all true premises is by definition sound. So that will allow you to eliminate 2 more among the remaining. Which 2? Pause now. Okay, hopefully you were able to figure this out, right? But the idea is that soundness is both validity and all true premises. So if you'll notice here, these 2 are valid and have all true premises, but they're saying that the argument isn't sound. Well, if it's valid and it's got all true premises, by definition it has to be sound. So these 2 are in fact not possible. All right, we're narrowing it down. 1 more among the remaining can be eliminated. I'll give you a hint in a second, but pause now and see if you can figure out for yourself which one among the remaining can be eliminated. Pause now. All right, hopefully you had a chance to figure this out, all right, but it's this one. This one is in fact impossible, okay? It cannot, no possible argument satisfies this description, has this property alignment, okay? So why not? Well, an argument which is sound is going to have, it's going to be valid and it's going to have all true premises, so all of that's good. The problem comes in here where it says that the conclusion is false, right? Basically, because it's valid, it's going to have, it's going to be such that the premises guarantee the conclusion if they're all true. On top of that, it's got all true premises. So if the premises guarantee the conclusion and all the premises are true, then the conclusion has to be true, right? So that one is in fact not possible. All right, so in summation then, we had a table of 16. We eliminated, 9. So we're down to a table of 7. 1, 2, 3, and then these 4 is 7, right? So we've got 7 left over, and these 7 are all, in fact, definite logical possibilities given our definitions. So in the textbook, and what we're going to do here is that we're going to leave it as a exercise for you to actually produce arguments that satisfy these descriptions, okay? So for example, go ahead and produce an argument that satisfies the description of being invalid, unsound, but has all true premises and a false conclusion, right? Now the big question is how are you supposed to just come up with, off the top of your head, an argument like that? Well, you can use the arguments that we gave as examples at the beginning of this video, and there's more in the textbook, as a template. Right, so at the beginning of the video, we gave you an example of an argument which was both valid and sound. That was the Wales argument. We also gave you an example, category or quadrant B, right, of an argument which was valid and unsound. So you can use that argument, that was the dinosaur argument, and you can tweak it a little bit to satisfy these properties. Right? We also gave you an example of an argument that was neither valid nor sound, and you can use that one as a template to sort of switch around its premises and its conclusion, trade them in and out for other premises and other conclusions in a way that you satisfy these properties. Okay? And once you've got and seen examples of these different types of arguments, you're really going to understand what's possible and what's not, and the nature of validity and soundness. All right, logic fans, good work. Make sure you're doing the practice problems, because that's what's going to make sure that you really understand these things. And the next video is on the all-important Law of Bivalence, so we'll catch you on that one.